Again, what is a flashpoint? Why do we test it, and how does it work? Flashpoint, and here I read to you the definition, is the lowest temperature corrected to a pressure of 101.3 kPa, so that's sea level pressure, standard pressure, at which the application of an ignition source causes the vapors of a sample to ignite momentarily under the specified conditions of the test. So the flashpoint is basically the temperature when you have a little spark in above the vapors of the sample, that it starts burning. But it does not mean that the sample then completely explodes and burns for forever, because when the sample continues burning, there must be enough energy already coming from the heat, either from the initial flash or from the sample itself. And when it continues burning, we talk about the fire point. And this is again much lower than what we call the auto-ignition point. Auto-ignition temperature is when a sample is so hot that it starts burning automatically. What we are measuring with our flashpoint tester is basically the flashpoint temperature. Why do we need the flashpoint? Yeah, basically it's something which you use especially to declare the safety for transport, classification of flavors, fragrances, paint, solvents, all kinds of samples that are flammable need to declare the flashpoint before you can transport them. For product specifications, especially for diesel, jet and biodiesel, the flashpoint is required, but also for other petrochemical products. And all this comes then into safety data sheets which are compiled out of this. What else is done? You can do combustion analysis, contamination analysis, determination of fuel dilution. That's a big application the military is using, because the flashpoint is a very fast and efficient way to see if you have any gasolines contaminated into diesel fuel or any light fuels going into lubrications and so on. So, just a second, my boss is calling, but he cannot call me now. So, turn him off, call him back later. Sorry for that. History of the MINIFLASH started basically by the need of the US Navy, who wanted to have a safe and simple flashpoint tester, and has approached Dr. Grabner to design a flashpoint tester which they can bring on ships, for example, and test if something has happened to the ship fuels. And then we came out with the first MINIFLASH series, single and 8-fold sampler has been done. We also have created a standard 6450 and 7094. And the standards are called continuously closed cup flashpoint test or modified continuously closed cup flashpoint testers, and are meanwhile used in many fuel specifications. Also here we have two newer generations. The latest one is the Vision, which we have just launched last year, and the Vision replaces the FLP Touch that we had since 2010. So how does the standard of the MINIFLASH compare to the classical standard, the D93 of Penske Martins? The Penske Martins uses 75 milliliters of sample, while we are just using 1 milliliter or 2 milliliter, depending on the standard which you are selecting here. But the key thing is that we have a comparatively much better repeatability and also reproducibility. While for 7094, the reproducibility was tested really with contaminated samples, sparked and spiked samples, and specially designed contaminations, because this was the reason why this modified continuously closed cup method was developed, to really cover and get very close to the results of the D93, the Penske Martins, also with contaminated samples. And this picture should show you which standard to use for which substances. So the 6450 is definitely good for all analytical grade pure substances, for gasoline, diesel, heating oil, but especially also for jet fuels. That's something where the Southern Research Institute in Texas has used it for. Contaminated products, when you have possibly a mixture of diesel and oil, methanol and biodiesel, or gasoline and jet, or flaming jet, that's something where you use the 7094. The design of the MINIFLASH is somewhat different from compared to classical designs of flashpoint testers. Typically, classical designs are heating from a cup of sample from the bottom. Here, we basically lift a sample cup on an open surface and heat it from the top. And this allows us to keep it completely closed continuously. And we have a spark source here, like this arcing is like a sparking plug in a car engine. And of course, for checking if the vapor is burning in here, you need to apply some air, and this air is supplied in here. Now, if you have a flashpoint here, of course, you have a pressure which is building up, and again, this pressure is then getting out here, and at the end, you have a pressure transducer. And this is how we are detecting basically the flashpoint. Here again, you see, you can select the settings for a certain sample. Just press the play button, and the instrument will guide you through. Will ask you for the sample, and then again you have a nice animation of what is currently going on in during the measurements. And finally, you have the result of your flashpoint test, and also a graphic. This graphic here shows you actually the flash pressure. And as I mentioned, when the flashpoint occurs, we are checking the pressure, and the pressure is much higher. And this is basically how this system is checking the flashpoint or detecting the flashpoint. Very unbiased way of checking it. A quick summary. It's a fully automated measurement. You are introducing the sample cup through the front door here. We have two types, the FP Vision and the FPH Vision, for two different sets of temperature. These temperature selections were basically selected based on user and customer input, and that's why we have optimized the temperature range according to these inputs. I've mentioned these standards. There is also a corresponding standard from IP, the Energy Institute, and then of course we are having correlations, especially with the Penske-Martin standard, but we have also no flash programs, dilution programs in there. And meanwhile, we are listed in several fuel specifications as alternative to D93 as a flashpoint tester, which is more efficient, produces less pollution, consumes less sample. Also, the latest technology has been used, which is making heat ramps much faster, as you can see here. And also the cooling follows a certain patent to make cooling and the cycle time of flashpoint testing much faster.